To study spherical mirrors, we use some terms. We consider certain points, distances and lines. We name them appropriately, like pole of the mirror, center of curvature, focus, pole of the mirror, center of curvature, focus, radius of curvature, focal length, principal axis, aperture of the mirror, etc. These are the terms that we are going to use in the study of mirrors. To study spherical mirrors, we use some terms. We consider certain points, distances and lines. We name them appropriately, like pole of the mirror, center of curvature, focus, pole of the mirror, center of curvature, focus, radius of curvature, focal length, principal axis, aperture of the mirror, etc. These are the terms that we are going to use in the study of mirrors. Pole of the mirror, it is the center of the reflecting surface. If you take a concave surface, the center of this reflecting surface is pole of the mirror. So pole of the mirror lies at the center of the curved reflecting surface. And the point, the center of the sphere of which the reflecting surface is a part, is called center of curvature. Center of curvature is the point of the center of the sphere of which the curved surface is a part. The focus is the point where the parallel beam gets converged in the case of a concave mirror, and in the case of a convex mirror they appear to converge, they appear to diverge from a point. This is focus. Then the distance from the pole of the mirror to the center of curvature is known as radius of curvature. This is also the radius of the sphere, from which the curved surface is a part. The line passing through the pole of the mirror and the center of curvature is known as principal axis. The distance from the pole of the mirror to the focus is called focal length. The diameter of the circular surface of the spherical mirror is called its aperture. Normal to the mirror, any line that passes through the center of curvature, any line from the surface of the mirror that passes through the center of curvature is normal to the surface of the mirror. So a normal to the mirror means the line that passes through the mirror, the line from the surface of the mirror which passes to the center of the mirror is called the normal to the curved surface, or normal to the mirror. The principal axis is also one of the normals. To the mirror. Take a concave mirror, hold it with its reflecting surface facing the sun. Then the light rays coming from the sun are reflected by the concave mirror. Hold a white paper. Keep a white paper in the path of these reflected rays, that is in front of the mirror, and move the paper back and forth until you get a sharp bright image of the sun. We can explain this image by considering the light rays coming from the sun. The light rays coming from the sun, after reflection, they converge to this point, and the bright spot is the image of the sun. This is also known as the focus of the mirror. This bright spot, the position of the bright spot is the focus of the mirror. Here, the rays are concentrated at a small region. Over a small region, the sun rays or reflected rays are concentrated. The sun rays carry heat energy along with light. They carry heat energy along with light. So the paper becomes hot initially, and then smoke comes out from the spot. Thereafter, it begins to burn. So the paper burns at the spot because of the sunlight. That because of the concentration of the sun rays at this point. This point is called the focus of the mirror. The distance of this bright spot from the mirror, from the center of the mirror, is called the focal length of the mirror. This is approximate focal length of the mirror. This can be, this in the figure, APB is a concave mirror. APB is a concave mirror, P is its pole, and PC is the principal axis. The principal axis. Two rays are incident at A and B, which are parallel rays from right to left, traveling from right to left. After reflection at A and B, these two rays meet at the point F on the principal axis. This F is called the focus of concave mirror. And the distance PF is known as the focal length. The distance PC is the radius of curvature R. By taking any number of parallel rays, we can show that all of them pass through F after reflection. So the rays which are parallel to the principal axis, after reflection, they will pass through this point F, and this point F is called the focus of concave mirror. In the figure, we notice a white curved surface, that is reflecting surface. This is the red one is the paint, and this is a convex mirror. The reflected surface is to the left. Now imagine that P is the pole and C is center of curvature and PC is the principal axis. Let us suppose several rays are incident on this curved surface, reflecting surface, traveling parallel to the principal axis. These rays, after reflection, they will diverge away from the convex mirror. And these rays, when they are produced backwards, these lines, the lines representing these rays, when they are produced in the backward direction, when they are produced backwards, all of them meet the principal axis at F. So we have to imagine that the reflected rays, they are diverging from this point F, and this F is called the focus of the convex mirror. The distance PF will be focal length, and the distance PC is the radius of curvature. PC is radius of curvature and PF is focal length. Focal length. It is the distance from pole of the mirror to the focus. The distance from pole of the mirror to the focus is known as focal length. Radius of curvature is the distance. from the pole of the mirror, to the center of curvature, Pole of focus. Focal length is represented by small f, and radius of curvature is represented by capital R. We can show that the radius of curvature is twice the focal length in mirrors. In mirrors, the radius of curvature R is equal to 2f, twice the focal length.